particular reason, I'm going to scan here and pick somebody. So here is the version of question 19. I'm going to do with limits of integration. I'm going to do the fourth root of 1 plus 8x. Let me just check that. I may change that number in a minute, but give me a minute to figure out a number that would work well with the fourth root. Oh, shooting space. 3. 3 would work well. What would that be? 3, 9. 3, 9, 27, 81. Okay. There we go. Okay, now hopefully we're up to speed. There's not an awful lot of choices here. Would you agree that the U sub is a pretty, I think anyway, a pretty obvious choice? What would the U sub be?
1 plus 8x.
Agreed. Aren't we using the rule if it's inside the square root, cube root, fifth root, right? Ugly guy inside fourth root in this case. Now, when you do this guy, the derivative with respect to x is just a number, which is nice. When you do the crossover, you get that. And when you divide both sides by 8, you get that. So, you do the integral. Do you see these limits of integration, the 0 and the 10? The 0 and the 10 belong with the x's. So what I typically do, so I don't screw myself up here, is I leave these numbers out. Just ignore them. It's best not to write them down, in fact. Now, this fella here becomes the fourth root of u, and the dx becomes 1/8 du. That's fine. I'm going to call this 1/8 u to the power of something du. I'm going to use the power rule. So won't this fourth root have to be converted into the fractional power 1/4? Are you comfortable with that? Right. If it was a square root, wouldn't it be u to the half, right? If it was a cube root, u to the 1/3. Now I can use the power rule. Add 1 to the power. Now dividing by 5/4 is the same as multiplying by 4/5. If you multiply this guy by 4/5, what do you get? You get a 10th. Now, normally I'd be doing a plus c here, and then I would change the u into that and we'd be finished. And that would be the correct answer, except we have limits of integration. So the difference here is that you don't do the plus c, it's not necessary, but you do return back to the x's. And then you do the style point. The fourth root of 1 plus 8x to the power 5. And at this point, you then bring back those limits of integration that I ignored. They're now back home. Do you see, you only put them in when you've got x's to put them into. Why do I not want to do that? The number of people who I've seen who've got to here and then go, boom, u equals 0 to u equals 10, and evaluate it as if these were u values. And it doesn't work, it's just wrong, right? So I tend to just not write it that way. If I don't write it, I'm less likely to screw up. Now, at this point in time, I'm going to rearrange how to do this calculation. Whenever square roots, cube roots, things like that are involved, it's sometimes better to find the root first and take the answer to the power of 5 than to take the power of 5 first and the 4. Can you imagine how huge that number is going to be inside the fourth root if I did it in this order? So let's see what it looks like in the slightly switched round order. 1/10 The fourth root, well, if you plug in 10 here, you get 81 raised to the power of 5. Take away 1/10. The fourth root, if you plug in 0 here, you get 1 raised to the power of 5. You know the fourth root of 81 is a nice number? Because I made sure it was, and most of the time the WebAssign will make sure it is. What number is the fourth root of 81?
Is that 3? Or
It is. No, you're right, it's 3. I mean, if you wanted to do it in your calculator, as long as it's a whole number, this will work. It won't work if it's not a whole number. But you could just go 81 to the power of, put it in brackets, 1/3. Sorry, I'll do that again. 81 to the power of 1/4. There you go. Do you see it's 3? So as long as it's a nice number. Now, I'm not finished, but I'm getting there. That's 3 to the power of 5 then, right? Get the answer, raised to the power of 5. Take away, can I just take away 1/10? Because isn't that 1 and 1 to the 5 is still 1? That's just 1. So 1/10 times 1 is this. Right, 3 to the 5, 3, 9, 243. Now, since WebAssign will want exact values, do you think that's correct? Look hard. Is there something I can do to make it nicer?
You can simplify it to 121 over 5.
Right. Now, little fiddly things like that will freak you out, and you think, you know, you do everything right, and then it keeps telling you it's wrong. And it was simply just a cancelling, a tidying up, right? Something like that. When you do the test, if this was the answer that you gave, WebAssign will give you 0 points because it's wrong. WebAssign just says it's right or it's wrong. It doesn't have any grey area. But I will be seeing you're working, right? And when I see you're working, I will say, yeah, okay, you didn't do it perfect, but I'll give you 18 out of 20 rather than nothing out of 20, right? You get almost all the points. So working is important. Are we good with that one? Okay. I'm just randomly picking things. Let's do a indefinite integral. Trig can sometimes just be a pain in the butt because they're just awkward. And every time you see a trig, you want to pause for a second before you jump head first in. What is the U sub here?
all of it? All of it.
Oh God, no, Dana, right? No, not going there. If you try to put that as your U sub, can you imagine what the derivative would look like? Right. Non-starter, not going to happen. Think small, not big. Any ideas of what the U sub in this question should be?
Would it be the tan cubed theta?
You're getting darn close to it. But just the tan theta. Well, let's find out why that one works and any of the others don't. By the way, tan cubed theta is not far away from being the right answer, right? It had the tan in it, wasn't that far off. But think about what you get when you differentiate your U sub. Wouldn't tan cubed theta get you 3 tan squared theta and a whole load of other stuff like secant squared theta after it? And that's probably not going to work because it's so ugly. Okay, this is memory. What's the derivative of tan theta?
Secant squared.
You might want before the test to make a nicer copy of one of these guys? Because if you look at it, not only does it tell you antiderivatives, but if you look here and go that way, doesn't it also tell you what derivatives are? For instance, the derivative of tan is secant squared. You see how this table works in both directions. Now, if I do my crossover, and then divide both sides by secant squared theta, you get that. Well, it's not so obvious maybe yet why that's a good use of, so let's keep going. I don't know what to do with the secant squared theta, so I'm just going to call it secant squared theta. Tan cubed becomes u cubed, and d theta becomes, do you see why tan theta was a good choice now? You see why? What's going to happen in the next line then?
Cancel out.
They do. And that's pretty much what we want, isn't it? We want our integral, once we've tidied it up and cancelled out, don't we want our integral just to have u's in it? In this case, u cubed. And this is a power rule. Add 1 to the power, divide by the new power. It's an indefinite integral, so we have a plus c. Return the u to tan. Finished. Side issue. 1/4 u to the 4 is 1/4 tan theta to the power of 4. But in mathematics, when you deal with trig, don't you call it tan theta with a little baby 4? There. That guy is that guy. Have you any idea why mathematicians, and this is pretty much universally acknowledged, why this is always written like that? It's a very simple, almost too obvious to be even thought about.
Would it be because you're raising the tangent to the 4th power, not the value like within the tangent?
No, not that reason. I can understand what you're saying. No, it's simpler than that. You don't need to use brackets. That's 2 things you don't need to write down. That's it. Just less work. Why do mathematicians never write 1x? We just write x, right? Why? Because you don't need to write a 1. It's 1 less thing to write down. Have you noticed that in math, it's like the essence of something? If you can find a way of not writing something, like if you can find a way of removing a bracket that you don't need or removing a 1 that you don't need, go ahead. I mean, what do mathematicians call 0x? In fact, you're that so used to it because you've never seen 0x, right? But what is 0x equal to? It's not a trick question.
0.
It's just 0. You don't need the x, do you? It's 0. It's nothing. In fact, we don't even write that, do we? So when you're in mathematic world, we have all these kind of little style point rules for making something as tight and as concise and as minimalistic as you can possibly think. I need to do a integral value one. We're going to do the integral from 0 to 1. This is kind of like question 16. We're in the U sub world. Just a standard U sub. What would work?
Eight plus x squared.
Right. Aren't we going to use the rule ugly guy inside square root is a candidate for the U sub? That's the ugly guy. Now I'll differentiate with x. I'll do my crossover and divide both sides by 2x to isolate the dx. Okay. Once you do that, aren't these three steps pretty much standard, right? Differentiate, crossover, isolate the x. Now over here, because it's a definite integral, I'm going to remove the numbers so I don't use them in the wrong place. I'm going to put the x in. I'm going to replace that with the square root of u. And then the dx gets replaced by that guy. And just as we were hoping, some cancelling. And now I'm looking at that guy. Are things pretty straightforward? This doesn't have any little wee kinks in it. It's going pretty smooth, right? Hopefully then you'll be able to tell me a different way to write a half square root of u. Because I got you integrated, right?
1/2 u to the 1/2 power.
Have we seen enough square roots in our life now just to do that without thinking? Have we got to that point yet? I don't know how many square roots. I'm guessing. We've probably done about 10 square root questions now, haven't we? Where half powers is where you go. Now, power rule. Add 1 to the power. Divide by the new power, which is the same as multiplying by 2/3. 2/3 times a half gets me this guy. Do I put a plus C on this? See shaking heads, that'll do. No. Make it look pretty, right? Style points. And now 0 and 1. Now I could have done this guy here and decided that it was going to be the square root of 8 plus x squared first, and then I'd cube the answer. Now, I did that earlier today. I think in this case, the numbers are so small, I could probably do it just as is. So I'm just going to leave this one alone. And let's see what we get. We get 1/3 the square root. If you plug 1 in here, 1 squared is 1. 8 add 1 is 9, so you get 9 cubed. Take away 1/3. If you plug 0 in here, you get the square root of 8 cubed. Yeah, seen better. That guy is 3 cubed, so it's 27. 1/3 of 27 is 9. And if you don't trust me, because I don't trust myself, let's see if I can do 1/3 the square root of 9 cubed. So I put brackets around things because you're never sure when you need them. There's 1/3 square root of 9 cubed. Nailed it. On the other hand, now that I've seen this guy, I'm going to change it to the square root of 8 cubed. I don't like 8 cubed. It's really, really big, and I'm not sure what the heck it's equal to. Well, I guess I could find out what it's equal to. It's equal to 512. I know that the square root of 512 is not an exact value, so I would need to simplify that, and that would be quite a big job. So back to this version instead. Can anybody here tell me what the simplified version of square root of 8 is? You did it, no, God, when did you do it? ND 94 or ND 99? Can't remember which.
2 root 2.
Agreed. Now, can't you do the square root of 2 and cube it? I know this is messy, but it's just as messy as that. That gets me 2 root 2 times 2 root 2 times 2 root 2 if you want to do it in full. That gives me 8 root 2 times root 2. Wait a minute, don't those two get me another 2? So it's 8 times 2 root 2, which is 16. So all that hard work, you will get 16 thirds square root of 2, and the first guy is 9. And as ugly as that looks, it's the final answer. So you may have to deal with some weird numbers and fractions when you do definite integrals. I think that's probably a great example of huge numbers inside square roots cause problems. Now, does anybody know how you would approach that if you wanted to get the 16 root 2 that I talked about? In other words, I want to simplify that down. I know, pardon me. I know eventually, anyway, I believe I know what the answer is. But how would you go about getting it? Wouldn't you have to find a really big square number times what's left over? Right. Can you trust me the really big square number is whatever 8 cubed is? Can you see how much more difficult it would be to simplify that guy than it was using this method? So that's the only reason I did this very long, messy thing, is because this guy was always going to be a problem. Now, if you're really lucky and it's a nice number, won't the calculator just tell you what the answer is? You know, if the answer is 4 or 7 or 7 thirds, won't the calculator be totally fine? Right? It's when the square root's not a perfect square, right? That little root 2. That's when you're going to have trouble. Any questions about that one? But I think most of the work was the number crunching. I think this bit up here was pretty obvious. This bit, not so obvious, in my opinion. This is question 15, version of it. In this question, you're actually given the use of. You know, trig's always going to be the one that gets us thinking. Remember the tan one that we did earlier? The use of ended up being tan. Any ideas what the use of in this question would be? And no, it's not all of it, right? We're definitely not going there.
Is it sine theta?
Slightly hesitant, but 100% right. Why did you think it was sine theta? What was it about this that made you go, yeah, sine theta looks good?
I just thought it's the most complicated part of this equation, and also the derivative of sine is cosine. So it would cancel the cosine.
That's exactly the reason, Brandon. When you look at trig u-subs, especially trig u-subs, but actually this rule works for lots of situations, but for especially trig u-subs, look at the ugliest guy, the most complicated. Typically, you might not choose the whole thing, but just look at the sine thing. Is the derivative of that this guy? And if the answer is yes, that's your u-sub. Remember the secant squared tan to the power of 5 thing? Wasn't tan to the power of 5 more complicated than secant squared, right? It was a bigger power. And wasn't the derivative of tan secant squared? So it kind of made sense. That's what we have. So d theta by du is cosine theta. Our crossover. And divide both sides by cosine theta. Kind of zoom through that line because we do so many of them. This fella, u to the 5. Just write the cosine theta down for a little while. Replace the d theta. They cancel. Would you look at how nice this integral is? I mean, isn't it really a baby integral as far as compared to some of the horrible things we had to do? Getting this guy's antiderivative is dead easy. It's a power rule. And since it's an indefinite integral, it gets a plus c. And if you replace the u with sine c, it's done. Does that look, now that you've seen the whole thing, does that look actually nicer than you might have thought it was going to end up?
And because we didn't do the u sub, we don't need to mess around with sine at all.
Yeah, there isn't in it. Now, I'm not doing this question in full, but imagine the exact same question, but with 0 to pi upon 4, right? Now, this would be a definite integral. This would be the same. All of this would be the same. Wouldn't the difference happen here? You would do all the usual stuff, and then you'd get to the line that looks like that, but you wouldn't put plus c in. You would just get that guy, right? Evaluated at theta equals 0 and theta equals pi upon 4. And then you plug in pi upon 4, so you'd get 1/6 the sine of pi upon 4 raised to the power of 6. So although I write it like that, when I do calculations, do you notice that I put the brackets back in the power? Take away 1/6 the sine of 0 to the power of 6. Okay, sine of 0 is easy, isn't the sine of 0, 0? So everything here is going to be nothing. Now you need your unit circle by you for the test, or that little, remember the little triangles I used? Whatever it is, I still need to know the exact value for the sine of pi upon 4. Who is that guy? I see some.
The square root of 2.
And?
Over 2.
Yes. Now, you might want that to be the answer, but you know it's not. You know with style points. And the big problem is, how do you do this to 6 powers? Well, here is one way to approach this question. Split it into the top piece to the power of 6 and the bottom piece to the power of 6. 2 to the power of 6 is, well, you could do it in your calculator, but here goes 2, 4, 8, 16, 32, 64. What about root 2 to the power of 6? Different approaches to the same answer, right? What could I do about root 2 to the power of 6? Because it must be equal to something, right? Now, it might be equal to a nice number, in which case the calculator would take care of it. But, you know, it might be, you know, 18 root 2, right? It might have a root 2 left over, right? So we've got to know, you know, how to deal with it in every situation. any suggestions about how you evaluate this as an exact?
The third power.
Say it again, Hector.
It seems like it's the same as 2 to the third power. So you can do 2 squared 3 times. Basically, you get 8.
Well done. Yes. So this is not what he said. He said it in a much better way than I do. But maybe people who are visual might want to see, isn't that just a very long way of writing this guy? Now, what happens to those two is you get 2, and to those 2 you get 2, and to those 2 you get 2, and doesn't 2 times 2 times 2 get you the 8? So this guy becomes 8. Do you think we're finished now? What should I do? You're right, we're not finished. What should I do?
You can simplify the fraction, divide the top and bottom by 8, and you get 1 over 8.
And would you agree that that just becomes 1/48? The minute they add limits of integration, don't they double your workload? I mean, it takes you twice as long to do the thing. So in the big scheme of things, you probably would like to see an indefinite integral, wouldn't you? Because you don't need to start figuring out how to get exact values of weird trig functions or root 2 to the power of 7, you know, some weird calculations like that, which will slow you down. But perfect answer. Okay. Now, this is, I'm about to show you a little trick here. It's a little bit of a long-winded trick, but it's worth it. I think. Oops, I think. Oh, let me change it. You can do a check that that answer is correct. And I'm going to show you on my emulator guy how I could do that same calculation and meet up with the answer. Now, the right answer was 1/48. Remember that. The correct answer was 1/48, right? So I'm going to go in, and you should be looking at a big version of TI-84 right now, okay? So hit y equals, and the original integral was sine theta to the power of 5 cosine theta. Now, I'm just going to put a bracket, sine of x to the power of 5. Right. You can't do sine to the 5th power. The calculator has to do it, you know, with the brackets. Multiplied by cosine theta. So cosine x instead of theta, but that's not big. So you type in the original function, right, before you did any u subs. That's this guy. You go to window and you put 0 in here and pi upon 2 here. And the reason is that this integral was from 0 to pi upon 2, so I did that. I'm then going to hit the button zoom 0. So if you can't follow all this, can't you just go back to the video and pause, watch what I did, pause, watch what I did. And it draws very slowly what that guy looks like. Kind of interesting shape. So once you've done all that, you're almost finished. You see up here in blue, it says calc, second button, calc. And choose number 7, option 7. And it says the lower limit, put in 0, hit enter. The upper limit, put in pi upon 4 again. And hit enter. And it will do a little, fill the thing in. Hey, what happened there? Fill it in, I tell you.
I think for the tables
You're-
that you did until pi upon 2, not.
Oh, darn it. Thank you. Okay, we'll do it again. Zoom 0. Actually, now that I think about it, would have worked anyway. But, okay. Not that different. Doesn't curve round. Right, second calc, choice number 7, lower limit 0, enter, upper limit pi over 4. And once it's filled this in, it will give me a decimal answer to that area. And the decimal answer, I'm having to write it down here, is 0.0208 and lots of 3's, right? And now I'm going to find out what 1 divided by 48 is. And it better be 0.0208 and some stuff. You see, it's a perfect match. So if you've done an integral, a definite integral, and you're not 100% sure, is my number correct, then couldn't you do, if you're careful enough, couldn't you do a similar thing to what I've done? And it would tell you what the decimal version of the answer is. And then you could look at your answer. Maybe your answer is √2 plus 5 √3. Yeah. Well, can't you find out what that is as a decimal? And if they're the same decimal, you've done it right. So it's a way of checking, not replacing, right? So you cannot take an exam question and just tell me the answer is 0.0208 lots of 3's. Because if you did do that, I know exactly what you did. And you definitely didn't do the substitution rule, right? Are we good? Right. Well, this is a good point for me to finish on this. And if you give me a few moments to close off enough windows, I think we're on the right one. We are good. Okay, where are you guys? I've lost you. I'm missing. Oh, here it is. Got you back again. Right. I'm going to share, if I can find it, this will. I'll put you over here on that screen, and I'll do this. Boom. Right. This is essentially what you will be looking at when you do when you go to Canvas. You're going to get your test, and it's on WebAssign. So come Tuesday at 1 o'clock, you're going to turn up, and as a Zoom meeting, just like we are right now. And at 1 second past 1, WebAssign will suddenly make the test appear. It will be available. And you will go in and click on it like you do usual homework assignments, and you will do the test, read the questions. The difference is you're going to write all the working. Right? You're going to do working on paper. You're going to write it all down on paper. And you're going to get an answer, and you're going to stick into WebAssign, and that's fine. And once the time is over, you have got half an hour to get all that working turned into a PDF. So if you've never had it before, this is new. So let me show you some of the things that are here to help you. This thing here says a link to Adobe Scan. What you have here is a piece of software that basically allows you to use your phone to take pictures of your working. And this program, Adobe Scan, will then turn everything that you've taken pictures of into a PDF. And then you can take that PDF and send it to yourself as an email, for instance, or whatever you do, and put it somewhere where you can get a hold of it, right? Call it working.pdf. Once you have done that, you will then go and click here. So you have until 2:30 to do this. So it's a little bit of wiggle room, probably more than you should need. And you click on this guy, and I've got a little 2-minute video that shows you how you can take the PDF of your working and upload it here, right, in this place here. What you go is, you hit that guy, choose file, pick your PDF, hit open, and then click submit assignment, and you're done. It's as simple as that. Want me to go through that step again? Well, eventually.
Is there a limit to the size of the PDF? Like,
I haven't had too many problems with it. Adobe Scans, everybody who's used Adobe Scan has been fine. So if you, I'm only giving you that as an option. There are other ways to turn your working into PDF. I'll give you an example. Do you know a lot of printers have a scan facility where it'll scan things? Can you just put all your working onto your printer and ask it to scan it as a PDF? One of my students, I haven't seen if this works, but he says it works well for him. He just takes pictures of all the pages of his working, and he puts them into, oh God, I've forgotten what it was. I think it was Paint. Do you know Microsoft Word? You drop them in as Paint or something. Maybe it wasn't Paint. Anyway, he dropped his images into, say, Microsoft Word, and then he saved that as a PDF. That works. There's other programs out there. There's a program called Cam Scanner that does it. You might already have some other program that you like because your English professor asks you to upload things all the time in PDF form. I don't care how it becomes a PDF. It just has to be a PDF so that you can load it into here. And here, just to remind you, is that link. So you click on that link when you've got your working as a PDF. The reason this says resubmit is, do you know sometimes you do it and then you forget, oh God, I missed the last page? Well, you can just add it to this one and write and download it. So resubmit, choose file, that one, okay, submit. Are there any questions, or are we comfortable about what the expectations of what I want you to do as far as working's concerned? Are we good with that? Right, next, your test is going to be on everything that we have done, with some exceptions. You're not going to get any questions involving finding left 6, right 6, or midpoint 6, trapezium 6, or any of the other numerical calculations. So remember those ones that took you 20 minutes just to do a question with all the numbers, those kind of questions? They are not going to be in the test. So that's good, right? Next, your test will only last 50 minutes, and that should be plenty of time for you. But if you have another class directly after this one, and you might think, I won't have enough time to finish the test, take pictures, make it a PDF and upload it, or for some reason, whatever other reason you might come up with, I can arrange when you take the test. Some students have access services adaptations, and those are good examples of that. So I don't always remember who's on it. So if you can just say to me, hey, I really need time and a half because that's what I get, or I really need a different time slot for whatever the reason might be, it's not a biggie, right? I can fix it, right? So I don't feel a problem with that. Now, what you're allowed to do and what you're not allowed to do, right? When the test appears on Tuesday, all your homework will disappear from WebAssign, just for a little while. So you can't go in and look at your WebAssign homework and see what, because it'll be just the same kind of questions as you got in your homework. You are allowed, however, to use anything that's physically written down. So if you've written a nice little table of standard integrals to help you, go ahead and use it. Can you imagine you may have written down some trig identities, you know, because you think, yeah, I got to remember what that is. Other things. You might have your unit circle handy, yeah, physically written down. I'm cool with that. You might have PDFs of these things because it's written neater in that form, and that's okay. So if it's physically written down or it's a PDF, you are good. You can use it during the test. During the test, there'll be a Zoom meeting, so I need to see you all. So get a camera, because I have to make sure that Hector or Jessica, or whoever it is, doesn't have their big brother behind them writing down the answers and showing them how to do it. Right?
I have a question about that.
Yeah.
I'm just going to use my computer, but because I have two computers, I'm going to just set this, like, I don't know, off to the side. Is that going to be okay?
I can see it. That's what I need to do.
Okay.
So you're cool.
All right.
Yeah. So I have Zoom. What else? You are not allowed to do tutoring. So don't go to tutoring and say, can I help with this question? Because that's cheating, right? Obviously. Don't phone your friend, because that's cheating. Although I guess I'd notice that one, right? What else? Don't go onto web blogs and sites where you can actually type in. It's a bit like unofficial tutoring, right? You can type in things and somebody in Kansas will tell you how to do it because they like math. Don't use those things. That's just not fair, right? What else? Homework. Working is vital. If I don't see the work into a question, you ain't getting any points. There is nothing you're going to do in the test that you can do in your head and just tell me the answer's 42. I mean, the one we just finished doing, remember that one, 1/48? Can anybody really honestly say that they could do that entire thing in their head and write just down the answer? It ain't happening, right? So if I just see an answer with no working, I'm assuming that you cheated in some way. You know, you can go onto all sorts of software and type in things and it'll tell you the answer. Right. So if I don't see working, you ain't getting points. And all of these things are basically to try and reduce cheating, so everybody's in a fair level playing field. Give you another example, not that you'd ever want to do it, Jessica, but you might decide to phone up Michael and say to him, Michael, how do you do question 3 in the test? And Michael could try and help you, but his question 3 will not be your question 3. WebAssign changes the numbers. I do more than that. I change the numbers and the question. So Michael's question won't be yours. It'll be similar, right? So they're both equally hard or equally easy, but it won't be the same one. It's called pooling. So I pool the questions and we randomize the digits. So don't even bother phoning him up because the chances are he won't have your question, so you just wasted 10 minutes. When you take all those things into account, to me, it's fair. It means whatever you got, you deserved it, right? You did it on your own hard work and not with someone else's help. Right, open questions now. Ask me some stuff. What do you want?
So for the Zoom camera thing, so do we have to have a separate camera that we're using to take the test?
I only caught the beginning, then your voice cut out on me, Camille. So you want to say that again?
Yeah, so we can't, for the computer and the Zoom thing, can we use the camera and the Zoom that's on our computer that we're taking the test on, or does it need to be a separate camera?
I think Evan was saying the same question. He's got 2 computers, so I'm assuming that the camera is being used on computer A, but he's doing WebAssign on computer B. Would that be a fair way of describing what Evan's doing? If you're lucky enough to have two computers, you could use one just so I can see you on Zoom, right? And you could use the other computer to do WebAssign test on. If that's what you're asking, you can do that. Is that what you're asking me?
I'm asking, can you use, if you only have one computer, can
Well,
you be on
you can,
Zoom
yeah,
and the test
yeah.
at the same
Well, do you know how in Zoom right now you're probably seeing everybody's face here?
Yeah.
You know, you can minimize that and just open up WebAssign and do WebAssign, and that's not a problem. I will still see you even if you cannot
Okay.
see me. So
Okay.
you'll be fine, right? So you can do it on one computer. Just minimize the Zoom page, right? The one with everybody's page faces on it, and just open up a link to WebAssign.
Okay.
Okay.
So is it fine with this view right here, or do you need
Yeah,
it to,
I
like,
just
see our
need to see you. If I can
papers,
see you,
or-
I can tell from your body language and the way you're looking that there's, well, I can't tell if you've got a 3 feet miniature brother behind you, but I can tell that there's nobody obviously behind you. And I could probably also tell if you're hearing things. It's maybe not foolproof, but it's better than not having nothing, right? So there an added advantage to having this Zoom. Can you imagine you're coming across question 4 and there's something just about it that doesn't look right? You could say, hey, I'm on question 4 in the test. Is this question right? I mean, because, you know, WebAssign sometimes screws up like everything. And I'll go and I'll go, oh God, that question's impossible. Sorry. Pretend that 4's a 3 and it's okay now. You know, that kind of thing. So I am here as help. And you might say to me something like, in question 2, do they want a plus C or not? And I could look at it and say, yep, it's an indefinite integral. So you do what that means. Any more questions?
Real quick, same as most other days, will you be logged on Zoom before the test? How long will you be?
I'll be in about 10 minutes earlier than usual. So I guess if you've got a last minute problem, you still have time for me to give you a question. What I suggest that you do is, since Monday is a holiday and I won't really be online on Monday, and you know, because there's no class, if you come across some homework question or a topic that's just not making sense to you and you want to make sure that you're ready for the test, shoot me an email. And if I can answer it by email, I will. And if I can't answer it by email, I'll set up a Zoom meeting, just me and you, and we can go over it. Okay? So that's kind of how we'll do that. Because sometimes you don't know what you don't know until you start doing the homework, right? And then you suddenly realize, oh, I don't know how to do this question.
Right. And you did say, my audio was cutting out. You did say 30 minutes, 3-0 for the test?
The test will last the entire 1 till 2, and then you have another half hour till 2:30 to upload, you know, do the camera stuff and copy your working and turn it into a PDF. So you have 1 hour for the test and then another half hour after that.
That makes more sense. Okay, thank you.
Gotcha.
Is the exam kind of like homework where you submit each question after you do it?
I would strongly suggest that you submit after each question.
Okay, so if we were to get an answer wrong, like writing it into WebAssign, and then
Yeah.
if we were to, I guess, maybe redo it on paper, will you still give us full credit for that, or are you, or do we get points off?
Okay, it depends how this works. Let me give you 2 scenarios. Scenario number 1 is, well, you're going to be doing the working anyway, aren't you? You're going to look at the question. You have to do the working to get whatever the answer is, right? And you get the answer and you put it in. And then you suddenly look at the work and say, oh, wait a minute, that should have been a plus, and you fix it, right? That could happen. I look at your working and that's where you're going to get the points from. WebAssign is going to give you 0 out of 20 because it's wrong. but I will see your working and you might get 18 out of 20 because you just made a little mistake. If you have written the exact working and everything is right and the answer is 24, but for some reason during the stress of the test, you typed in 42 into WebAssign, then in that case, I would give you all the points. The third possibility is you do a question, you get the answer, and then you go, ugh, and you do another version of the question, right? In that case, you would lose some points because it's a second version of the question, but you'll get the majority of them. So you don't typically lose a lot of points if the working is good and the method is good. And if the answer is perfect, that's even better. WebAssign will not tell you if you got it right or wrong. So you won't even know that you're wrong, which is fine because that's, you know, a test. When you do a normal test, you don't get told. The paper doesn't say, that's wrong, right? So WebAssign doesn't tell you either. Any other questions? Okay, y'all want to say hi right now while you might be thinking of a question. We're coming to the end of today, so anybody who has maybe a question that you don't want to share in front of the rest of us, you can hang about and I will answer that. And that will be cut out of the video of today, so nobody will hear about it. And if you've got some homework questions, we'll do that as well. I'll probably keep the homework questions because I think they're helpful for people. The video from yesterday hasn't made it yet. Canvas went wonky last night. I couldn't upload a darn thing. And I've been teaching all day. So sometime later today and yesterday's video will appear. So everything will be there eventually. Okay, bye-bye, guys. Those who have everything they want answered. Anybody else, you want to start asking some more questions?
Thank you.
You're welcome. Bye-bye, guys.
I just had a quick question about the test.
Go.
Is it okay if we use our calculators? I know you said we could use physical pieces of paper for things.
Uh-huh.
Oh, awesome. Thank you.
Well, that was me just thinking out loud. So I'm trying to think of what your question is. You can use your calculator to do obvious calculations, right? Sure. Can I use my calculator to do that? Check that the area is right? Sure. Yeah, you can use that. That's fine. I'm trying to think of what you could use it for that wouldn't be fine.
Games.
Well, like in constants.
Well, yeah, but that would be a bad idea in a test. So I'm assuming that you would probably not do that of your own accord. Yeah, I can't see anything you could do on a normal. Are we talking TI-84 here?
Yeah, like the only thing I could think of was in my physics classes, they told us we couldn't like save certain constants on there, but I don't really remember how to do that anymore anyway. So
Well, we don't have any constants,
exactly,
so I guess that's not a problem.
Exactly.
But yes, is the short answer. You can use your calculator for all the usual things that you would do anyway.
Cool. Thank you.
You're welcome. Any other questions?
Yeah.
Yes.
I have an appointment on the 21st, and
okay.
It's in Port Ludlow, so I don't know, but it's at 2:30. So I don't know how long it's going to take me to drive there, but it's
I
possible.
don't think is 21st a problem. 21st is not a problem for us. That just might mean you'll miss a day in normal class. 19th is the test.
Yeah, okay, no, I'm talking about could I like leave early and that would be okay without any problems?
Oh, for that, yes, of course. Okay. Not a problem.
All right.
Just say hi early so you get the attendance.
All right. Thank you.
Okay. Who's next in the list of questions?
All right. So I was looking at section 5.5 on WebAssign when you shortened it.
Yeah.
And some of the problems I did yesterday after class, the points are transferring over weird.
Oh, I didn't know it would do that. Is it telling you you're now wrong when you used to be right?
It's still showing that the answers are right, but I only got 3.3 or 3.03 out of 4.5 points. for the assign.
It did that for
one
me, but then it
problem.
refreshed.
Right, try refreshing and see if it'll fix it.
I mean, for me, it like probably took 10 minutes, I'd say, to transfer over. But it did the same thing where it shows like 3 out of 4, even though I got it correct.
Okay, if
I
it
refreshed
still isn't, if it's still not fixing it, it's an easy thing for me to do. I can just go back and essentially there's a feature that says rescore. So
Alright.
you won't lose points in the wrong. So if it fixes it, you know, with a refresh, then this conversation's over. But maybe when I see you on Tuesday, you can tell me, hey, it never fixed it. Then
Alright.
I can go in and fix it. It's very easy to do. You won't lose points.
All right, thank you.
Okay. Any questions left?
I had a quick one on the homework.
Sure.
So
What
it's the same section, like the 5.5.
Which one is it? If you
It's
tell me,
the
I could
very
oh,
last
just tell me what it
one.
is. Write
Okay.
it. Say it out loud. It'll save
Well-
me having to open up a window again.
The question I have is specifically for finding the derivative of u. So I believe u is a squared minus x to the 9th. And I'm just, because I know so a squared
Well,
you have to leave in there.
Right. Now let's see. There is an original integral to this, isn't there?
Oh yeah, it's
So what was the original integral?
x to the 8th and then times square root of a squared minus x to the 9th.
Okay, that
Times
makes
dx.
perfect sense to me. Right. Let me go onto the white screen and show you what's going to happen here. Right. I'm assuming that they gave you the U sub, but if they didn't, it was the right U sub to use. Right. Now, the A gets used, but not in the derivative, and I'll tell you why. A is considered a constant, just means it's a number. If you differentiate any number, don't you just get 0 out of that?
Oh.
So when I differentiate this, all I will get is -9 x to the 8.
Okay.
Is that enough, or do you want me to keep going?
I think that's enough for me to solve it.
Okay.
Okay. Thank you.
Right. You're welcome.
Is that step because we're taking the derivative with respect to x,
Yes.
not a?
Yes.
Okay.
All right. Thank you.
Okay. If you're good, Jessica, have you got a question for me?
Yeah.
What you got? Is it something you want to just talk to me on my own, or is it okay for Mark to be here?
Oh, no, yeah, it's fine. It's just a homework
Okay.
question on
Yeah.
5.4. Question. Question 11.
Is it something you could read out to me, or is it too long? If it's too long, I'll go and look at it. But if it's something that you can read out to me, I'll do it.
I can probably read it out. It's the
Okay.
integral from 0 to 1/2 dr divided by the square root of 1 minus r squared.
Okay. I'm going to rewrite this guy just slightly differently. Okay. This is the same as that. Now, do you remember the antiderivative of a guy that looks like that?
Arc sine?
Yeah, inverse sine. So inverse sine of r, because the variables are, evaluated at 0 and evaluated at 1/2. Now we have the inverse sine of 1/2. Take away the inverse sine of 0. Think of the inverse sine as what angle has a sine of 0 and what angle has a sine of 1/2. Right, what angle has a sine of 0 is 0. What angle has a sine of 1/2?
Pi over 6.
Okay, so let's show you. Now, I've just typed into the calculator inverse sine of 1/2. I'm now going to do